Here is a list of parameters we might wish to specify. We can put search criteria in this box, or we can choose from a list of standard queries. For example, if we are interested in M42, we can select cone, enter the name of the object in the search box, and enter the desired search radius. Now we will open a query I prepared earlier. It's a cone search around the center of M42, which will retrieve all the brightest sources. Let's launch the query. Okay, the Chandra source catalog has returned a list of 39 sources. If you want to explore some of the sources at a glance, simply click on this symbol to pull up a color image of the source. Every energy band is represented by a different color. We can also view individual images from the different bands. There's the broad band, the hard, the medium, and the soft. And so, we can see the differences in the same region of the sky at different energies. We can also view the image of the full field where the individual sources are located. To do further analysis, we can select all the rows of the table, all the sources retrieved, and using the SAMP protocol, we can seamlessly deliver this table to the application TopCat, which is a tool to manipulate and analyze tabular data. You can see here that a table has appeared in TopCat. We can have a look at the rows and columns of data, or we can produce simple queries and plots. For example, a scatter plot of the positions of the sources. We select the relevant parameters, RA and DEC. So, here are the positions. We can also color code by other parameters. For example, significance, which is in some ways a measure of how bright the source is. You can see that the brightest source is the one at the very center of the plot. We can also produce more complex plots, for example, three-dimensional plots. Select the hardness ratio HS for the x-axis. The hardness ratio is basically a ratio of X-ray fluxes. On the y-axis, we will plot the flux in the broad band of the source. On the z-axis, we will plot the hardness ratio MS, medium and soft band. We can view and manipulate the plot just by using the mouse. I will unselect the transparency so we can see all the sources well, and we can also color code the points of the plot using the same significance parameter we used before. Now let's go back to CSC view and unselect all the sources. Then jump back to the 3D plot. Let's say that I'm interested in investigating only some of the sources further. Using the Select tool, I can draw a line encompassing a subset of points. Then, using the SAMP protocol, I can send that subset of points to CSC view just by clicking Transmit Subset. You can see that only the sources contained within the selected region have been highlighted. Now I can retrieve data for these selected sources. For example, let me retrieve images and light curves. I could choose to download these files, but we can also get a sneak peek at this data using other SAMP-enabled tools. For example, I want to see the image associated with the region of this source. I can select the file and send it to the application DS9. And there we are. Now, one of the questions I might have is, which of the sources visible in this image were actually detected in the X-ray observation? So I go back to TopCat. I can select the table containing all the sources we retrieved using CSC view, and I can broadcast this to DS9. This window pops up indicating that DS9 has received the table. Now, if we shift back to DS9, we can see that small green circles are located at the center of the sources that were detected with the Chandra X-ray telescope. Now we can select another data product, a light curve, for example, and send it to TopCat. I can produce a plot of the light curve, adding errors in the count rate. Now we go back to CSC view, unselect this light curve, go back to the results page, and unselect all the sources. We can also use the same plot to select other sources. For example, I can select this source here, and then send it to CSC view. Now we can see that the row associated with that source is highlighted. Then we can select the spectrum of the source and send it to TopCat. But before we go back to TopCat to see what the spectrum looks like, we can unselect this one, go back to results, and unselect the source. And now we can plot the spectrum using a simple scatter plot. I'll do a little tweaking of the graphical parameters, and there we are. This is our first spectrum, the spectrum of this source, right here. Now let's see if there are any differences in the spectral shapes associated with the different sources in this hardness ratio plot. I can select another point, which is located in a quite different region of the plot. And send it to CSC view. Now we see that there is one row highlighted again. We can retrieve the spectrum of this source. and then send it back to TopCat. Now, we can overplot the spectrum of the second source onto that of the first just by adding the spectrum and doing the same kind of graphical tweaking. Here we are. The spectra are quite different, which is as we expected. But we can do even more. Virtual observatory technology is not only for sharing data between applications, but also for accessing data from observatories all across the world. Let's go back to our first table and ask, are there any near-infrared observations of the same sources we have observed in X-rays? We'll look for two mass observations. Here, we have selected one registry, which is essentially a phone book of all the resources available to the virtual observatory. We'll look for two mass sources, and we will also specify the name Kutri, which is the name of one of the authors of the catalog. Then submit the query to retrieve sources associated with these two keywords. There. We have found the all-sky catalog of point sources from the two mass data. Now, we can positionally cross-match our X-ray detected sources with the sources in this catalog. As you can see, we've set the search radius to 1 arcsecond, also telling the software to ignore any errors. And now we can launch the search. It shouldn't take long. A table containing all the data associated with the sources which have infrared counterparts appears in the main window of TopCat. You can see that only 27 out of 39 sources detected by Chandra have infrared counterparts. Let's see where these sources are by going back to that first plot we produced. I'll unselect the color coding, and I can add the position of the infrared counterparts. For clarity, I can change the symbol. So you can see that only these sources have infrared counterparts. This demo has been focused on two different aspects of the virtual observatory: the interoperability amongst VO tools and the idea of the registry, which allows astronomers to draw on a huge range of data from different observatories across the world. Thank you.